Alright, try this one again. I accidentally screwed up on the last one I did 12. I looked at the wrong numbers again. But we got -5, 2, and 9 given to me. These have a difference of 7. This is arithmetic. As I move to the right, I add 7 to it. It's arithmetic. So, because it's arithmetic, I have to use a different formula. The nth term of an arithmetic sequence is the first term plus n minus 1 times the common difference d. I'd say 3 out of 4 of you kind of know this one, because a lot of you are leaving off the plus symbol, but you have an idea of it, which is something. The first term in my sequence is -5. N minus 1 difference is 7. Put it together. Eighth of n is -5 plus, invoke your distributive property, 7n minus 7. The nth term is 7n minus 12. And I don't want to waste time writing this, but if I plug a 2 into this thing, that would be the second term. 7 times 2 is 14, minus 12 is 2. If I plug a 3 in, 7 times 3 is 21, minus 12, you get a 9 back. It works. I did this one. I need to make these so that you can do it easy and then you can use a formula, because I know the EOC, sometimes they put easy stuff on these. So find the sum of the 4th through 9th terms. As soon as I figured out that I was adding 7, I could just go ahead and write down the whole pattern. Next one would be a 16, a 23, a 30. By the way, it's the 4th through the 9th. 37. 7 and 37 makes what, 43, 44? And the 9th term would be 51. I could see me messing up adding 7. For some reason, I've always kind of struggled with 7s. But anyways, I don't know. It's weird. I believe those are right. What I would do is I would just take these guys right here and I'd add them all together. I could do that. It's not hard. I do have a personal preference though, and that's a me thing, and it's probably going to be for some of y'all who just don't want to do it this way. It's going to be 201. I like formulas. I do. To find the sum of n things, it is the first term that matters. Sorry, it's n over 2, wrong formula in my head, n over 2 times a sub 1 plus a sub n. If I want the sum of the 4th through 9th terms, I do 9 minus 4 is 5, add 1 back, there's 6 things. So 6 over 2. And the first guy is the 4th guy. So I probably wouldn't have written this out. I would have said a sub 4 is 7 times a 4 minus 21. That's what I would have done, which would be, sorry, 12. I'm having dyslexia today. 28 minus 12 is 16. I'd have put a 16 there. And the last guy would have been a sub 9. I'd have done 7 times a 9 minus a 12. That's 63 minus 12, which is 51. And I'm just saying, this is what I'd have done. I'd have known 6 over 2 is 3, and if I didn't have a calculator in front of me, wouldn't have picked it up. 201. They both generate the same answer, but I did design this so that you can do it the easy way, or you can do it using a formula. 13, I didn't feel like making up something similar. So here we go. These are your zeros. Zeros are where you cross the x-axis. They are the x values. There's a lot of kids who are missing these. The x value is where you cross the x-axis. So there's a 0 at -1. There is a 0 at 0. And there is a 0 at 2. Multiplicity. It's written right off on here to the side. If you touch it, it happens twice. If you cross, it's a 1. Touch, touch, cross. Touches happen twice. Multiplicity is 2. Touch, multiplicity is 2. Cross, multiplicity is 1. That's how hard multiplicity is. Now, by the way, while I'm doing 1, I'm going to go ahead and do 4. because they're the same thing. If x equals -1, then the factor is x plus 1. Now its multiplicity was a 2. You can put a 2 there if you want. If x equals 0, then the factor is x minus 0, which becomes x. And the multiplicity was 2. Put a square there if you want. Lastly, you have x equals 2. Jump that 2 over, x minus 2. There's your three factors. Degree and sign of a polynomial based on n behavior. So there was 4 little graphs that you had to memorize sometime last fall, maybe late summer. I don't remember. You had x to the even, which is a high situation. You had negative x to the even, which is a low. You had x to the odd, which is going to be a low high. And then you had negative x to the odd, which is a high low. This thing starts high, ends low. Negative x to the odd. 3, least degree of the polynomial based on turning points. The least degree is the number or hashtag of turning points plus 1. This bad boy has 1, 2, 3, 4 turning points. Take your 4 turning points, you add 1, you get at least x to the 5th. So look back at what you have up here. 2 plus 2 plus 1 is 5. Those usually correspond. 5 was an odd number. These 3 pieces always reinforce each other. Part 5, the factored form where you find a. So I'm going to take my existing factors. I don't know why I opened up a set of parentheses, so I'll just put it at the end. I had this factor x plus 1 all squared. I had this factor x minus 2, and then I had x to the second. And I'm just going to write down the default without an a value. Then I'm going to take this point right here that gives me an x and a y, and I'm going to plug that in. Everywhere I see a y, I'm an 8, and everywhere I see an x, I'm a 1. Remember, that piece is squared. Then I'm going to crank out the math, kids. 1 plus 1 is 2, 2 squared is 4. 1 minus 2 is -1, 1 squared is 1. And I get that 8 is negative 4a's, which means my a value is -2. So my full equation is y, or f of x, whatever you like, is -2. I'm going to put that x squared out first. -2 times x squared. Put x minus 2 in second, and then x plus 1 to the second power. There's a reason I wrote it like that. Generally, if it's just a nomial instead of a monomial instead of a binomial, we put them first, and then we increase exponents. 14 is not a bonus. Simplify such that all exponents are positive. What I suggest you do is move negative exponents around. That's what I suggest you do. I would move your negative exponents around, at least initially. Then you can simplify. And always, do 4 over 20. That's 1 in 5. I don't like that this e to the negative second is negative. So I'm going to put it right next to e to the 5th. Oh, I hate these. I got an x to the 5th and I got an x to the 7/3. Bummer. That does stink. Okay. E to the 5th times e to the 2nd, e to the 7th, we add exponents. I'm thinking about x to the a times x to the b, where we add them. This little piece right here is going to be a real bummer for some kids, okay? You got to ask yourself what's bigger, 5 or 7/3. I would move, and you're actually doing the property. But I think it makes sense for kids to move it down first because kids have an easier time understanding you add exponents when you multiply as opposed to using subtraction when you divide. And if you don't know what 5 take away 7/3 is, shame on you, right? It's 8/3, I think. Yeah, 5 minus 7/3, you can push the buttons. Math, enter. There you go, 8/3. And crap, I didn't do a similar one. This was how you do that one. 5e to the 7th, x to the 8/3. All right, next one. Right triangle ABC with C being the right angle has side lengths x and we'll say BC is 10. Write a simplified expression representing the cosine of A. Some of y'all don't draw triangles like me and it shows. Write them like me. A to B is x, side BC is 10. I have no idea what this little side is, but I need it for cosine because cosine is adjacent over a hypotenuse, which means I need that side. So I'm going to call it A. Then I'm going to do this really old theorem called Pythagorean theorem. A squared plus 10 squared is x squared. A squared is x squared minus 100 because 10 squared is 100 and we would subtract it. And then A would be the root of x squared minus 100, which you cannot do anything with. This is not, and I repeat, it is not x minus 10. You can't do anything with it. It's not 100 x squared, it's x squared minus 100. This is your missing side length. That's what she is. Now you can do cosine. Cosine is adjacent, the root of x squared minus 100, over the hypotenuse, which is x. In calculus, you actually have to rewrite the trig functions so they are functions of x. It's kind of interesting. We no longer use sine, we use an actual function. Like that. It's kind of interesting. Find the difference quotient. Let's see here. I can look at this equation and tell you it's going to be 6x minus 2 plus 3h. How did I do that? I didn't do the difference quotient. I did something else. I did a shortcut. And if you can figure out that shortcut, awesome. If you can't, you got to do the difference quotient. I'm going to find f of x plus h, which means I plug in an x plus h everywhere I see an x. I'm going to FOIL this thing out. I'm going to distribute. Now I'm going to clean it up. Then I'm going to plug everything I can into this thing. I always do this piece separately. There's some people that write this all as one gigantic fraction. Don't do that. What I mean by that is they'll actually put this in right here. This should be worked out separately. I've never seen anybody, well, I repeat that. I have seen teachers who make kids work this out all inside a fraction. Don't be that kid. We're taking away f of x, 3x squared minus 2x plus 2. We're going to wrap that. It's all over an h. And there's always 6 things that cancel out. You have 3x squared minus 3x squared. You have a negative 2x minus a negative 2x. And you have a positive 2 minus a 2. There's always 6 things that disappear. Always. Now you're going to be sitting pretty at 6xh plus 3h squared minus 2h over an h. That particular fraction has 4 pieces, and every piece has an h. 6x, right there, gone, minus 2, gone, plus 3h, which is exactly what I told you it was 2 or 3 minutes ago. See if you can figure out the shortcut. That's called derivatives.